So let's talk about electrolytic cells and quantitative relationships. There's a simple relationship between the amount of electricity that we pass through our electrolytic cell and the amounts of substances that get produced by oxidation or reduction. The more energy we use, generally the more reactants we use and the more products we make. So let's think and this whole chapter, this whole section is really just about dimensional analysis, just all kind of ratios. So if we consider the half reaction of silver ion plus an electron to make silver metal, it takes 1 mole of electrons to make 1 mole of silver. Okay, that's the relationship in the reaction. Or we could say 1 mole of electrons to make 107.9 grams of silver, because that's silver's molar mass. But if I look at copper 2 ion, the half reaction for it being reduced, we can see that now I need 2 moles of electrons to make 1 mole of copper, because it's a 2-to-1 relationship. Okay, or again, I can say 2 moles of electrons to make 63.55 grams of copper. Okay, so you might see just stoichiometry, just sort of dimensional analysis here. Okay, what if I was trying to reduce gold 3 ion? If you look at that half reaction, hopefully you can guess that it's going to take 3 moles of electrons to make just 1 mole of gold. Okay, or 197 grams of gold. So it depends on the half reaction that we're talking about. So let's define a few things, some really important terms and relationships. Here we're going to talk about the quantity of charge. Okay, the unit of charge is going to be a coulomb, and it's abbreviated with a capital C. And an important relationship here that is, if you have 1 mole of electrons, they have 9.648 times 10 to the 4th coulombs worth of charge. Hopefully that you might recognize as Faraday's constant from earlier. Okay, so this is going to be a relationship that we're going to use in our stoichiometry. We're also going to talk about how fast current flows. When we talk about current, the unit of current is an ampere, or some people just call them amps. Okay, or you just put a capital A for amp. Okay, and 1 amp is 1 coulomb per second. Okay, so when a current of 1 amp passes through an electric circle, 1 coulomb of charge passes a given point in the circuit each second. Okay, so we get 1 coulomb of charge passing through each second. That's what 1 amp means. Okay, so it tells us how fast our charge is flowing. Okay, we're also going to talk about electrical energy and the units of electrical energy, and really all energies are joules. Could be calories, but we're only going to use joules. Okay, with a J. And a joule is 1 coulomb times volt. That's just a relationship that might be helpful. Now, if you look at an electrical bill at your house, there's a different unit of electrical energy. It's called a kilowatt hour. Okay, it's not a different thing, it's just a different unit of energy. It's called a kilowatt hour. kWh. And 1 kilowatt hour is the same as 3.6 times 10 to the 6 joules. You do not have to memorize this, or 3,600 kilojoules. Okay, I'm not going to make you memorize a kilowatt hour. So this table is an attempt to summarize everything for you. Okay, so we have different quantities that we need to talk about. There's charge, okay, which are measured in coulombs. A coulomb is an amp times a second, or a joule times a volt. Probably not going to need to worry about that too much. And this is really important here. 1 mole of electrons is 96,480 coulombs worth of charge. Now you don't have to memorize that because that's just Faraday's constant and that'll be given to you. Okay. Current, that's how fast charge is flowing. That's measured in amps. Okay, so coulombs per second. Voltage is measured in volts, okay, which is joules per second. Power, that's how fast you can do work, or measured in watts, which is a joule per second. And energy is measured in joules or kilowatt hours. Okay. Yeah, I got a mistake on here. I'm just looking for it. Yeah, this one right here. Voltage, this should say joules per coulomb. I was like, they can't be the same. So joules, let me write this. 1 volt is 1 joule per coulomb. Okay, so that's just a summary of things that are important to know. And in the next video, we'll go through an example and see what all this looks like.